All right, welcome back. We are Game 3001 in the winter 2021 semester, and it is week 11, really, but learning week 10, and it's uh, state machines. We're talking about state machines again. It's part 2 of our broadcast. In part 1, we really went over what state machines are and how to use them, how to create a state machine, and we drew a diagram that looks something that looks like this, where you say, like, here's a state machine. What I want to do for this lab, I'm just going to go back to that. What I want to do for this lab is, if you kind of look at the goals, I want to convert to a finite state machine, right? So I want to try and do some of this. There's a lot of work involved in doing this part. So this is the majority of just setup, right? And then building a state machine and running the state machine is going to be the last part. We may not get to running the state machine properly. I'm going to try my best. For lab 8, what I'm looking for is if you give me a snapshot of your code so that you show your effort that you've done your homework and coded along with me. I think that's what I'm looking for. If we get to the point where I can actually do the build and run, that would be great. It just takes a while to code all the classes and everything else that we want to do. And I'm going to use the classic generic finite state machine example from the book. That's how we're going to do it. So on that, then, let's get to it. So I want to go into our starter. So here's our starter. We're going to download this, and I've already gone ahead and done that. So here is our starter. There's our starter right here. I'm just going to unpack it and then start off a brand new project. So this should say 8B. Just doesn't like that, eh? 8B. There's 8B. And then under 8B, I'm going to start this off. Now, while this is loading, let's talk about some other thoughts here around this. I'm not going to do a hierarchical state machine. That's just too much to to get moving on, right? So what I want to do is start with this part right here. So this part right here is really what I want to start with, okay? I don't want to do the other parts, just those parts, okay, if that makes sense to you. Let me just go and I want to look at the color puck. I don't know why this all turned out, but hey, it's okay. The brush palettes and the brush library, as well as the layers. There we go. And I also want to show the toolbar. I don't know why that all turned off, but whatever. It's just turned all off. But what I meant is, so just to show you again, I'm looking for just to get this area right here is the part that I care about. I don't care about the damage piece and this part. I'm not going to do this because then I'd have to do a hierarchical state machine to do it right, in my opinion, right? So this is what I'm going to try and focus on, just this part. Which means there's only 4 states and there's really only 3 transitions, right? If you think about it, right? So I have line of sight, that's a transition. Detect radius, that's a transition, right? I'm close, that's a transition. And then if I'm not close, that's the opposite of close. It's the same transition, right? Or it's the same, so I'm going back to move to player, that's a condition, right? So these are conditions. Lost line of sight, well, that's like not having line of sight. So it's the same condition, right, if you will, just the opposite of that. And there's only 4 states, so there's only 3 transition types. Either I'm moving here, I'm moving there, or I'm moving there. So 3 transition types, 4 states, but only 3 that are going to be regularly active after the initial state. All right, so that's how it's going to work. Okay. So again, that's we're starting from a fresh kind of version. I'm going to go to Team Explorer this time around, and I'm going to go to Home. I'm going to add this to Source Control. I need to do that too. And I'm going to go to Changes. There's all these changes. I'm going to make an initial commit, and I'm going to publish to GitHub, where it's going to go into George Brown College, Lab 8B. And that'll be our final. So it's going to take like 1 step, 1 click, and done. There we go. And so what this is going to do is if I look online now, for this, no, this, there we go. If I look at line down for this, then what we want to do is grab this thing, 8b, and that'll be our final version. Whatever that turns out to be, that's going to be our final version. So I'm going to add that as a final. So web link, and then we'll say lab 8 final. And by the way, like I said, there's a lot to code here, so bear with me. Neil's asking for the assignment 3, do we need only idle and patrol? The answer is yes. You don't need any of this. I'm showing you this because preparing you for assignment 4, which is just around the corner. All right, so that's why I'm doing it with you way early. And also, you may decide that you want to use a state machine instead of a decision tree or a behavior tree, and that's why I'm doing state machine today. Okay, so just to get you warmed up is what this really is really about. And warm up is really a broad statement here, as you'll see. All right, so so one thing as we get going, I've started it off. I've got everything up on GitHub for you guys to start off. That's awesome. And so if you've got your a version of your decision tree working, I'm totally fine with that. But for people who don't, I'm going to make a new area. I'm going to rename this decision area to decision tree. And I'm going to make a brand new filter, a new filter called state machine. So we know that we have a state machine filter and a decision tree filter, and then you can look at those two examples. What I'm going to do is agents, I'm just going to leave agents where they are. Conditions, core components, I'm going to have those two. So let's add in some new core components, so new filter, some new core components for this one. And some new conditions. So I need conditions, I need actions, and I need, and that's really it. The rest are all kind of core, right? So let's add them in. So I'll add in a new filter called conditions, and I'll add in a new filter called actions. And we'll start with conditions, because let's think about the code that we're talking about here. If I look over at the code and I go way up to the finite state machine example that was in the book, look what it's saying. It's saying, okay, I'm going to start with some kind of null transition. That means I need a transition. In order for me to get transitions, for the state machine, each transition is going to have a bunch of actions. A bunch of states. So transitions are going to have states. But if you look further down, right, and you look at the code, state has a bunch of transitions. So transitions have states, states have transitions. Cyclical reference. We got to work our way around that, right? How that works. Transitions have a bunch of actions, right? So we need to have actions. If you think about that, without actions, we really can't do transitions. But really, this actions is a transition action. If there's a transition action you want to do or not, I'm going to say that we're not going to do transition actions, just to keep it simple, because it takes too long to code all this stuff. So that's one thing. When you go down to transition, so I have transition actions where I want to get an action. I get the target state, that's cool, and I get is triggered or not, is it triggered or not. But I also need to know conditions. So I can't do a transition without a condition. I can't do a state without a transition. That means conditions have to come first. And that means I have to start here with this simple class. All right. And again, I'm showing you this because you got to look at dependencies. One thing depends on another thing, depends on another thing. Let's get back to this. So I want to make in my core components brand new. Oh, first of all, let's clean up my scene, okay? Because my scene is kind of full of stuff. I want to go to playscene.each. And I want to scroll down, get rid of our decision tree. We don't want that. So no decision tree anymore. And we want to go to our playscene.cpp, and what we want to do is clean up any reference to our decision tree. So all this stuff is gone. That was from last day, so this will be a new day. So none of this stuff. We don't want this stuff here for now. Okay. And what we want to do is close this off for now because we want to clutter this. There's a lot to do. I'm going to start off with some conditions. So let's start off with a core component, the core condition component. So new item, I'm going to make a new condition component. And by the way, I'm thinking about making the condition component first, because without that, then there's nothing else can rise from it. So conditions are things that drive our state machine anyway. So condition.h, okay, that's what it's going to be called. And again, we need to put it in the right spot. It has to go inside of src folder, select folder, and let's click add. We want to do if not defined condition, right? And define condition, and then end if. Our class condition is going to be its own class, not going to derive from anything. We're going to have a public area and a private area. And I want you to think of what this is. Our public area is going to have a condition constructor. And the condition is going to take a Boolean. So let's suppose that I want to have a condition that I want to set up by default. So a Boolean condition that's going to start off at false. Okay, hear me here for a second. My condition Destructor is going to be like this. I'm going to make a virtual Boolean test function, and I'm also going to have a void set condition method that I can set the condition of whatever this thing is from outside of the class, right? So I want to be able to do that. And I'm also going to store data in terms of m_condition. So this condition is just going to be a true/false state, if you will. And the state of the condition, whatever the state of the condition is, what this is, you can actually call this state, but I'm just going to call it condition so that way we don't get totally confused. All right, so that is the first part. And it looks pretty simple, but let's build it out because it needs its own little implementation. So again, I'm going to right click on my core components. I'm going to add a new item, and I'm going to talk about a CPP thing called condition.cpp. I'm going to include the condition.h class. Here's my condition.h class. And what I want to do is implement all these things. So generate definitions by declarations. It's going to do this. I'm going to make this default. And in my condition, I'm going to set my condition to whatever it is. So I'm going to say that for this condition, I'm going to call the setCondition function. I'm just going to pass through the condition, which means this can be const. This is my constructor. And then as well, I'm going to say that m_condition is equal to condition. So this is just a way of storing data in my class. And the data that I'm going to store is a true/false statement. By default, it's going to store false. My test, though, is going to basically return, by default, return m_condition, whatever it's going to be. So whatever the condition happens to pass in, it's almost like a pass-through function. And there's also a little tidy fix that I want to put in, so to set up the m_condition as just a, this kind of makes it so it's false by default. Okay, so that's the condition class. Let's put this up on GitHub. So again, I'm going to go to Team Explorer, and I'm going to say, I'm going to do a lot of this, so bear with me. So home, I'm going to go to changes. I'm going to say I added condition class, commit all, and then I want to go to home, sync, and push. So you have all those, that condition class is done. By condition class, and hello conditions. So this is the condition class. Well, my conditions, like in the book, right, has several, right? We have a float condition, and we have a and condition, and a not, and an or. There's different kind of condition types where you can combine conditions to create a lot of variation. What we need is this float condition as well. Let's get that float condition going, right? So again, I'm going to go in and let's suppose I want to make a new item and it's going to be a .h. We're going to call this the float condition. Float condition. My float condition is going to be very much like my condition, if not defined. Float condition and define float condition and then end if. Okay, and what I'm going to do with this one for my float condition is very similar to what I've done with my condition, but we're going to add additional features. So class float condition is going to derive from a public condition class, right? And the condition class, of course, is going to do this. It's going to add the condition in there. And what I'm going to say is float condition is we're going to make a public constructor, and we're going to have some private areas too. And the way it's going to work is I'm going to have a destructor, and my float condition is going to take a couple things, right? It's going to take a min value, and it's going to take a max value. So anything between min and max is what's going to make my condition work. Float min, float max. And what I also want to do for my float condition is have a void set test value. So set test value. And my test value is going to be whatever value it is. So that's going to be like, let's suppose I want to do a distance. I want to know if I'm close enough between 0 and whatever some value, 2 pixels. If I'm within 2 pixels, if this value is within 2 pixels, then the float condition passes. And that is going to be my Boolean test. Okay, so my test is going to be something that I want to override, right? Because I'm overriding the initial version of my class. So this is kind of like I'm using polymorphism to override. I'm not making my condition class abstract. What I'm doing instead is I'm just using it as a base class for this one. Okay, and then what I want to do is have some value, some min value. I want to have a max value. And I want to also have a current, let's call it test value for now, a test value. So a min value, a max value, and a test value. Okay, that's what we have for our condition. Let's do our generate definitions by declarations, but we can't do that because we don't have a CPP yet. So we'll add a new item. We'll add in a CPP that is the float condition. Float condition. So include float condition .h, and now we have enough. So we can do that generate definitions by declarations thing. Again, we're going to start with a destructor. We're going to make that defaults for now. Our float condition, what we're going to do for this one is set our min and max values. So I'm going to say m underscore min value is equal to min value, and m underscore max value is equal to max value. This is in the float condition constructor, right? And if we want to be smart, what we can do is we can set up some defaults. So we'll say that the min value is equal to 0.0f, and the max value can also be equal to something. For example, 1.0f. So something between 0 and 1, right? Again, it's just defaults so that if I set up a condition really quickly, I can get it going without having to worry about these. So these now can be consts as I'm getting a value inbound, right? And then I want to set my test value. So I'm going to say m underscore test value is equal to some kind of value. And again, just like I did before, what I want to do is set some, there's no default value for this. It has to be something that I test. My test is going to basically say I want to return m underscore min value is less than or equal to the test value. If that's true, and I also want to test that m underscore test value is less than or equal to the max value, right? If that's both of those conditions are true, if test value lies between min value and max value, then we're good to go. Now I've broken it down like this, but you can actually combine these two things here and make it one big statement. I'm not going to do that. I'm just going to make it like this so you can see the difference. All right. And that's my test. That's my float test. Right. So test, it's going to basically say, like, you know, when I set it up, I'm going to have a value that I'm going to pass in. And the reason why I want this value to be passed in, this set test value, is so that way I can set it every time, right? This float condition, whatever it's called. And this is like how close I am to the player. Am I close to the player? All right. If I'm close enough to attack, kind of thing. Because that's my float condition. Let's put that up on GitHub. So Team Explorer, home, and I go to changes, and I want to say added float condition. Okay. All right, so that's my float condition, and I want to think about the next part. So now that I've got a couple of conditions, I could add my and, my not, and my or, because that's what it tells me, that there's some options where I want to add some combination of things, and, not, and or. I'm not going to do this to save time. You can do this very simply. It might look something like exactly what it looks like. I'm just going to have something that tests the condition, a test, all right? But more or less, it's going to be 3 new classes, and I'm not going to add them right now. But you could totally do that if you wanted to. All right, so that we have a couple of conditions. One of them is the core condition, and the other one is the float condition, which is the 2 that we need. We're also going to do some actions. So let's think about what the action is going to look like. I'm going to start with the core action, right? And this is similar to what we did with the action class before, but I'm going to start off with this core action. So add a new item. I'm going to call this the action item. I need actions, because if I don't have actions, then I can't do anything. These are all building blocks that I'm using right now. So here's my action. Now, I want to talk about this action a little bit when I make it. So again, it's if not defined action, define action, and then end if. Okay. Same thing as we normally do to start off. What I want is a class that is an action class. Now this is going to be an abstract superclass. So this is more like a interface. So action interface. Why? Because I'm not going to really have anything that this thing does, right? In fact, if anything, I can even make this a struct, but let's just not go too crazy here. So what I'm going to have is an action constructor, which is going to be set to default. And I'm also going to have a virtual action destructor, which is also going to be set to default. And then I'm going to have a virtual void execute function. And my execute function is what I'm going to do when I activate my action. So I'm going to say whatever that action is, execute. Okay? And that's going to be my interface. It doesn't require a .h, because this is literally just the interface of what all actions are going to look like. All actions are going to have an execute function. Okay, just similar to what we did last week. All right, so now that we have an action and a condition, we can set up some more actions. So let's add some actions. This is important to add because these are our base actions. So again, I'm going to come up with the type of action I want. I can't call them, just to specify, because I have actions from last week and I'm not deleting them, like the attack action, move to line of sight action, move to player action, all these same actions, I can't use these because these, although they're similar, are inheriting from action node. And action node is a type of tree node. I'm not redoing these, but more or less they look identical to this. So what I want to do is get the attack action going and then rejig it. So get the attack action, and then I want to rejig all these. It's going to help me code faster. And that's what I want to do, right? Because I'm just copying and making a new structure, right? So new item, I'm going to call this the action with no attack, with no action at the end, just because I already have attack action. I'm just going to call this attack. Okay, so add, and then let's just paste all this, right? And we'll just exit out of this is identical, really, right? Because we want to make it so that, you understand what this is. This is of type action.h, right? Makes sense. And this will be the attack action, but we're not going to call it attack action. We're just going to call it attack. All right. And instead of action, it's going to be execute. That's it. So that is more or less what the attack action will be doing. I'm just literally just copy pasted from my action that I had before. Okay. And similarly, when I make my attack.cpp, so I'm going to add a new item, and we're going to make our CPP version now, attack.cpp. Again, a little bit tedious, but we need to do it. I'm going to include the attack action, which is this one now. And then I'm going to generate definitions by declarations. And when I do so, I'm going to set these things to default. Really, I could do this in one, right, as an example. But I'm not doing it. I'm just I'm trying to help you guys. And the reason why I'm doing it this way is so that way you guys can go and modify stuff and you're good to go. So my execute then is going to say something like what we had before. So if I go to the attack.cpp, performing the attack action is going to be the exact same. I'm not going to change that, as an example. So that's going to be the same thing I'm going to do there, but I do need a IO string. So include IO string. Okay, so that's what that is. And that should be public action. Why am I getting this? Declared upon attacks. Didn't make it public, didn't I? It made public right here. All right, so let's look at the action.h. Action.h. Oh, yeah. Thank you. Otherwise, it's private by default. Thank you. Which fixes this and which does this. And I think we're good. So that's our first action, the attack action. We only need a few of these. So let's add the next ones. So again, just like we have here, move to line of sight, move to player, and player patrol action. So let's do that. So we'll do the next set of actions. And again, guys, bear with me. This is all building block stuff. So add new item. We'll call this the patrol action. And I can't do the other one because I'll break them. That's why people are like, why can't you just use the other ones? No, I can't. But I can copy paste, right? There's nothing wrong with that. And modify. That's pretty quick still, right? So, we don't have to worry about making it all up, but, there's going to be some adjustments. It's going to be called patrol instead of patrol action. It's going to use the action.h instead of the action node. This will be the action. As an example, this will be called patrol. Like, you get it, right? It's not like it's that difficult. So please do that and don't wait for me to do it. So that way we're good, right? So, and this way we can do it fast. This will be execute, right? And then we can do is let's make the .cpp. So actions, add a new item and .cpp. We'll make this called patrol. Right? And we'll generate everything. Believe me, when you didn't have these automatic generation options before, back in the day, guys, everything was by hand. But people still do that, So let's make sure that everything is saved. Patrol action, we don't care about that. We want this one to be done. Yeah, and it was all done by hand, right? So, there's a lot to do, and we don't have a lot to do here, believe it or not. It just takes time because we got to slog through it, right? There is no way of doing this faster, except for there's a bit of copy pasting that we're allowed to do because we can do this, right? So we don't have to type all that out because we've already done this last week, so then it's the same, right? It's almost the same. So that's our patrol action done. Okay, and let's get the next one done. Almost there. So we have attack, patrol, add, new item. Let's do the next one, move to line of sight. Let's move to line of sight. We'll add that in. Let's add them all together. And we'll add a new item. We'll do this, move to player, and we'll add in their CPPs, right? Move to line of sight, and move to player. And then I'll put this up on GitHub in a second for you guys. Move to player. All right, and now that we have this, we can say that this, I want to include move to player .h, and this one is going to be including move to line of sight .h, and then move to line of sight .h is going to be very similar to move to line of sight action. So I'm going to grab all this and just copy paste into move to line of sight .h, and just change this from action to whatever it was, right? Again, bear with me. This is the tedious part. Actually, it's kind of all tedious in some ways because we're redoing some of the same things we did last week, right? But not to worry. It's just that we got to go through this exercise. I think it's a good exercise to go through actually because the great thing about this is it broadens your understanding of putting together classes. I think it does a lot in terms of, hey, what about if I wanted to quickly put some stuff together? You know, how do I do that? How do I put a state machine together? Well, there's work to be done. It's not impossible. I'm going to skip over to move to player action now and get that done. Move to player action. Because, you know, at the end of the day, right, and again, this is just my idea behind it. It's a good exercise because it gets you familiar with you know, the kind of the inner workings of different structures. I think is important to understand. And these are two structures that are very common: trees and state machines. So it's not like you're never going to see them again, or the effort is going to be wasted in terms of how this all looks. It's not quite like that. So you know, I think there's a great advantage, you know, to doing that, right? So to go through and understand all this stuff, and once you practice even by typing this stuff, I think it really goes a long way into move to line of sight action CPP. It goes a long way into you know, kind of move to line of sight. This one, move to line of sight action. This one. Goes a long way to understand it, because I think once you've gone through this exercise once, then I think that you can benefit a lot from it, because then you've done the inner workings of this stuff. It's not just a copy paste exercise, but actually what you get to understand the, you know, the way things are strung together. And I think this helped me a lot when I was first learning. I was like, hey, how do these kind of link together? And what about if you have cyclical references, which we're going to have in a sec? How do we take care of that? And then when do we test? And then, like lots of questions, right? And you don't know those things until you actually, you know, go through the fixing the problems related to these things. So that's why I think it's important to see it, and then hopefully you'll have a chance to, you know, you'll figure out some stuff, because once you've seen this problem one time, then it becomes easier to deal with the next time. Okay, so those are all of our actions now, and I'm just going to shut all these down and put them up on GitHub for you. I think I did mostly everything correct. There may be some typos and stuff, and if there is, we'll figure out that in a second, but I'm going to put this up on GitHub really quickly. So again, I'm going to go to home, I'm going to go to changes, I'm going to say added actions. Okay, so commit all, home, sync, push. So now you have all the actions, base actions. And now we have the basis for making transitions, and we have the basis for making states. Without actions and conditions, we can't really do transitions or states, right? So that's something that, like, one thing depends on the other thing, like I said. All right, so we can close that down because now there's new stuff. So we've got a bunch of actions, we've got a bunch of conditions, 2 conditions, and now we need some more core components. One of them is going to be the transition component, right? We don't have transitions, but we're going to make a transition component, a new item. It's going to be transition.h. And transitions are more complex, but not much. So transition there we go. Header. Transition is not going to inherit from any other class. There's going to be a public area and a private area. Okay. And again, we've got some basic things going on, but let's think about what transition is going to do. So I have a transition constructor, and my condition constructor should take in, this is where it starts, right? The transition itself is going to go from, where I am right now to a new target state. So I need 2 things. I need a condition pointer, right, which we will talk about in a second, which will be called condition. And I also need a, and by the way, I'm going to do some stuff here. I'm also going to need a state pointer, which I don't have, which is really the target state. So now you can see that before I even start transitions, it's like I need states and conditions, right? Well, conditions, no problem. I can add in condition.h here. So include condition.h. So that is the default, right? I have condition. I'm also going to be able to keep track of the condition that I have. I want to keep track of it as a piece of data. So I'm going to say, because it's going to be an object. So m underscore, it's going to be of condition type. M underscore condition. So that's the one thing. So when I make a new transition, I need to know what the condition is that I'm going to use to trigger the transition, right? Don't worry about this yet. We don't have a state, okay? And the other thing is we want a destructor, and we also need a Boolean, something to check if it's triggered. We'll say is triggered, right? It's going to return const, yes or no. As well as I want to get, if I want to access the condition, sometimes I need to, condition pointer. I want to get the condition that's associated with my my transition, whatever it is. Sometimes I want to get, just once I set it here, I want to get it. So these are getters. And I also want to be able to set it offline. So these are setters. And I want to be able to do that. I'm going to say that void set, well, a couple things I want. I want set target state. Set my target state to whatever the state is going to be. I don't know what that is yet. We don't have a state. There's no state class. And so I'm just, kind of talking about this so you see it. There's no state class. And I also want to set is triggered. Why? Because I want to be able to trigger this from outside, right? Which is the state. So is it triggered or not? As well as void set condition, right? Let's make this a lowercase. I'm using lowercase. I'm going to use lowercase. Right? Let's set the condition offline instead of doing it through the constructor. I want to give it ability for me to do it this way too, where this is the condition. So far I've got this red area for state. I also want to keep track of my target state. So I want to do that. And as well as my is triggered. Is it triggered or not? Which is triggered. Right, so that is kind of where my transition is going to look like. All right, I'm still got some holes. These are the holes I got in my thing because I don't have a state class. I don't have a state class. So transition depends on state. I don't have a state class though. And I also need to make a transition.cpp. Let's do that. So again, right click, I want to add a new item, and I want to call this transition.cpp. It's going to include transition.h, not transform. Transition.h. There we go. All right, and then what I want to do is let's make those declarations if we can, even with these errors. Generate definitions by declarations. Let's do that. And my destructor is going to be default. Notice it didn't pass in the stuff that I can't get. I'm going to return m underscore is triggered. And my get condition, I'm going to return m underscore condition. And as well, in my set is triggered, m underscore, whoa, the spider remember. So this is the is triggered is equal to state, whatever that is. And then my transition, if I want to set condition, I want to get the condition in there. So I'm going to say m underscore condition is equal to condition. So that is going to be all that I can do. Why did I not get the other ones? Because they've got holes in them. I got holes in my bucket, right? Something's wrong. I can't do set target state because I don't have a state yet. I don't know what that is. But I can do the rest, and I started off pretty good. Let's keep going, and let's add in a state now. So I have transition, but I need state. So how does this work? So add a new item. We're going to call this item state. Again, this is our building blocks, right? So here's our state. I'm also going to immediately add a new item for state.cpp, just so that way, we don't have to work so hard later on. So there's state.cpp. I'm going to include state.h. And in my state.h, I want to think about what this is going to mean for me. State is pretty big, right? I know I need to, if not defined stuff, state, then I want to define state and then end if. These are normal things. And the class state doesn't depend on anything, but we have a kind of a tightly coupled dependency. And we have to think about what this means. So state. So now that I have a state class and I've just done this, just this, then if I go back to my transition.h, then what I need to do is I can add a for declaration, or I can just do include, now this is dangerous, state.h. It really depends where you're going to do this, whether you're going to do it here or whether you're going to do it in state. Either way, one has to depend on the other one, because I'm going to have variables here and stuff that I'm going to be using, right? So I need to be able to create this reference, right? All right, so now we can make, going back to our transition, let's do generate definitions by declarations, the ones we're missing, which are going to put them in the right spots. Transition, here's our transition constructor. So we're going to say that I want to, two things. I want to set the target state to target state. I want to be able to do that. And I want to set the condition, right, to the condition. So I want to kind of use the setters for this. Same thing with set target state, right? I want to do the same thing here. So I want to say set target state is m underscore target state is equal to state. So that kind of covers the two features that I was having a problem with, right? And now this little underline, that means that's just for initialization, which I'm totally fine with. And then if I go back to my transition class, it's done. So my transition really does this. I need two things, two pieces of information. If anything, if you think about it, a transition is a pair. It's like a vector, if you think about it. It's a condition state pair. That's what a transition is. A pair of conditions and states, right? That's what it is. I have a condition and it pushes me to a state. That's what it does, whatever that condition happens to be, right? All right, so this is good. Let's close this off. And this is our middle place. I'm going to put this up on GitHub. So we made the transitions class. So I know we're not complete with the other ones, but this is how we build, slowly, right? So changes. I'm going to say added transition class. Okay, so commit all, home, sync, and push. Wonderful. All right, so that pushes up to GitHub. And now let's fix state. So state, that's a little bit more complex to do, right? And let's talk about this again. So I need the state constructor. I need a state destructor, right? So those are normal, right? State, structure, and constructor. I'm going to have some getters and setters, or get accessors, set mutators, however you want to say it to me. We've got to think about how this works. And then there's going to be some private stuff. Now, in the documentation, when it comes to state, this is one of the first things they talk about is, here's our transition. And then when they get into state, which is further down, they say, here's the condition, blah, blah. And then we get into writing about states. Hold on a second here. Let me make sure I get the right reference for you guys. They start talking about this, that the state itself, state machine is going to return a bunch of actions, right? A series of actions that you're going to do, not one, a series, okay? And it's also assuming a bunch of stuff. It's assuming that we're going to have a list of actions, more than one action, right? And it's also assuming that we're going to have entry actions and exit actions, as well as transitions, whatever it is. I know there's going to be more than one transition, for sure. But I don't know, at least in my state machine, that I'm going to have any entry actions or exit actions. So to avoid these and to make my implementation simpler, but not complete by any means, I'm going to avoid entry actions and exit actions, as well as make my state only have a single action associated with it, okay? Not multiple actions. So only one action it can do, all right? Now, not because I want to make it so that it's not functional for you, but I want to keep it simple for this one. And then we can always expand this and make it different later. Like we said, make it work, and that's it. So for my private state, instead of making it a bunch of vectors, which I kind of tried to do in the first section, and with some success, I would rather do something like this. I want to make multiple, a vector of transition pointers. So that definitely is something I want, a vector of transition pointers, right? Because I'm going to add a bunch of transitions in terms of how it's going to work. And the vector of transition pointers is going to be called transitions. I don't know what happened, but I'll include vector. There we go. So a vector of transition pointers. That's definitely what we need. All right, and I'm going to have one action associated with my state. One action, one state. Okay, so we're going to say that the action that I'm going to have is the state action. So we're going to say action pointer, right? And I want to have a single action, so action.h. I'm going to have a single action associated with it called action. Again, keeping it simple. We can go crazy and add all kinds of other stuff, but you know, why? I want to keep it as simple as possible. I'm just sorting some of these for now. All right, so transition, and there's one action, and I'm not going to have entry actions and exit actions, just one action. That's what it's going to have. All right, so then our getters and setters are going to be are simplified as well. In our getters, we're going to have the ability for me to get transitions. So I want to get a reference to my transitions. So I'm going to say that standard vector of transition pointers is going to be get transitions. So it's going to get the array basically, or of pointers, right? So that's what it's going to be. Let's just not make that constant now. Let's just make it like this. So that is a set of transition pointers that we're going to add in, right? And then what I need to do is I want to get action. So I want to say that standard, instead of a standard pointer, it's going to be an action pointer. And I'm going to say get action, which is going to return the action. So that's my the pointer that I want. I also want the ability for me to add a transition. So kind of a getter, but more like a setter. So because we're setting something, I'm going to, any kind of adding or whatever, I'm going to put it here under setters or mutators, right? So I'm going to say void. We're going to say add transition. Okay, now this is where we get a little hairy. We're inside of state and we're talking about transition, but transition depends on state, right? Transition, I'm even surprised that transition was even allowed. Transition depends on state. State depends on transition. We're going to have a circular reference. So what do we do? Instead of doing this up here, instead of that, we make it a friend. And again, you can put it anywhere you like, where if you put it here, you can say public, sorry, a friend class, which I'm going to call transition. We won't have the implementation details of what this class would look like, but we're forward declaring it. So we're saying it exists. It's definitely something that exists, but I can't declare it here because if I declare the transition here and try to include it inside of my transition here, so I'm including state here, and if I include transition here, then they're going to include each other. And I can't have that. So I'm going to just basically say, hey, transition exists. It existed before state. And state depends on transition, and transition depends on state. So we're just going to make it like this. So at transitions, get transitions, we're going to return a bunch of transition pointers. And by the way, we have to also think about the more logical thing to do, right? If I look at state.transition.h, transition.h has target state, right? And so there's only one, okay? And also there's one, kind of a couple places where we're doing something with state. So we could also do a friend class here. It's not impossible to take state out of here as well and make it forward declare it as friends on both sides. All right, we could do that. Okay, I'm just saying. So it's there's possibilities on both ends, but let's continue. So we want to add a transition, and the transition is going to have a couple of options. One is I want to be able to add in a transition that's been declared by itself. So when I add in a transition, we're going to call this a transition pointer, right? So this is a possibility where I can add in a transition itself. Okay? Transition, right, gives me a couple of options as well, right? When I create a transition, right now I'm required to add in a target right away. But how do I add a target state when there's no state yet? So I'm going to make it so that in transition, I'm going to say that by default, we don't need to. Okay? We're going to set it to null pointer. In fact, let's set both the condition and the null pointer. This is inside the transition class. So just in case I can make the transition empty first, and then set target state and set the condition after. And let's just change the order of things so that it follows the constructor. Set condition, set target state, and then is triggered or not. This is in the transition class. Okay. And by the way, it tells me that I can make a derived class. It's got this little underline that says a non-default destructor, but does not define a copy constructor. And that's why it's like, hey, are you sure you want to do this? And if I go to definition, it says apply a tidy fix of this. Well, I already have a transition.cpp which does that, which makes the transition default. So I don't want to do it there. All right, back to state. So state, now we know that transition is a friend for now. and we want to add a transition. So that's one of them. The other way to do it is maybe what I want to do for my state.h is give myself a convenience of adding conditions and states by myself. And that's another option where I kind of add in a condition and a state, and I create my transition inside of my state. I don't recommend that. Let's also add an action. And I'm going to say there's an action pointer related to the action that I'm adding. Okay? And really, if you think about it, that's it. That's my state. So state is only going to have one action and one or more transitions, because we're going to have a transition vector, right? All right, now let's do the next part, which is inside of my state.cpp, I want to generate definitions by declarations. Again, what we'll do is we'll make this, both of them default this time. So when we create our state, we don't need to set up anything because we have more than one. We're going to have more than one transition, and we're going to have an action, but we're going to set the action and the transition afterwards. That's how we're going to do it. So get transitions, we're just going to return m_transitions. And get action, we're going to return m_action. In our add transition, we're going to say that m_transitions dot pushback, and then the transition that I'm going to pass in. So this is like a wrapper for the pushback function. I could do it here too by getting transitions and pushing back the transition, but I'm going to do that with a wrapper. Same thing with my add action. I'm going to say that m_action is equal to action. So this is kind of like just a getter or a setter, sorry. I'm only going to ever be able to add in one action. And so add action really could be called set action. Let's just rename that. So rename, refactor, rename. Let's add this to what it should be. It should be called set action. So set action, and this should be add lowercase add because we've been doing lowercase everything else. So refactor, rename, and we'll do a lowercase add transition. All right, so it looks like this: set action, add transition, right? Because there's only one. If I said add action, you would get the idea that I can add multiple actions. And here I'm making it simple, and there's not going to be anything. Sean says transition is not allowed for me. Yeah, it shouldn't be allowed. Shouldn't be allowed because transition should have a transition, thing, and then state, because state is being called, and state is also got a state of here. Then because state is included in transition, then when I add transition, it's including itself. Can't do that. So it's got to only be one way or the other. All right, so that is your state. So state's very simple. Again, questions so far about the building blocks that we've added. So state, condition, transition, action. Those are all the things we need for a state machine. Okay. Let's put that up on GitHub. So I'm going to go to Team Explorer. I'm going to go to Home. I'm going to go to Changes, and I'm going to add. So I'm going to say added state class, right? So commit all, home, sync, and push. All right, so we've got our building blocks, but we haven't tested a thing, like nothing, right? As an example. And I think one thing we have to do before we move forward is test, but let's continue. And this is where people run into problems. I'm warning problems, because we haven't tested a thing, nothing. And so we're going to have to test, but they're all related to each other. That's the challenge when we do any kind of thing. Even the last time we did a decision tree, all the components were related to each other. So that's why we have to have components in order for us to test. So in our core components now, let's add the state machine component. So I'm going to add new item, and we're going to call it state machine. By the way, you could also call it FSM, finite state machine. Some people have seen that as well. It's smaller to implement. It's not a bad thing, but we're going to just call it state machine because it's not that big. And we're going to make the .h first, like normal. and we're going to say that if not defined state machine, then define it. And then end if. Wow. Okay, give you a chance to catch up to my bad typing. Okay. So state machine, what the heck is this going to look like? Is it insane? What does it look like? It's insane. Oh, sorry, let's go back to state for a second. So if I go back to state.h and state.cpp, one thing is that we're talking about a transition, but we don't know what that is. So let's put transition here. Transition.h. Sorry, that would be very bad if we didn't do that. We need to be able to put it somewhere, right? So whether it's here or whatever. And again, I'm a little bit concerned because we also have a state. We have a transition array, a list here, right? may want to reverse it. We may want to add transitions in here for states, and then in the transition make state a friend, because there's only one state, but there's multiple transitions. So this is where I get into a little bit of a kerfuffle in terms of my brain. I'm like, wait, whoa, it's an alarm, something's wrong. So state machine then is, again, I'm going to have a public state machine, and in state machine, I'm going to have some getters, and I'm going to have some setters, and I'm going to have some private stuff. So in my private stuff, let's think about what I need. I need some kind of state, right, which is the initial state, m_initial state. That's like our root, if you will, of our machine, right? The initial state. So that's what we need state for that, okay? We also need a pointer for current state. So what is the current state? I should be able to get the current state, set the current state. I also might want the target state. And I want them all separate because I want to be able to look at those. I'm also going to have a the transition that's being triggered, right? And I want to think about this because every time we go through it, I'm going to change the transition that I'm checking out. So in the book, it says triggered, and I want to look at the, almost like here. Let me show you what that looks like. So the pseudocode for the state machine, I'm just going to show it to you here. It looks like this, right? Where basically what's happening is triggered is a transition, right? And we set it to null every single time we come through here. So we come through, we set trigger to null, and then we say, okay, if our transition, for every transition in transitions in our current state, whatever that is, then if the transition is triggered, then say that triggered is equal to the transition. So we kind of set the transition to whatever the transition is, all right? Almost like a triggered transition. That's what it is, right? If the trigger transition is something and it's not null pointer, then what we want to do is we want to set the target state to the triggered transition's target state, whatever that is. We want to set up a bunch of actions, and then finally we want to set the current state to the target state based on what we had before, and return an actions array. That's what we're returning back here. And we're doing the same thing if we don't have a transition that's being triggered. We just keep on returning the current action over and over again. Yes, that's what it does. Kind of it returns the action over and over again. We're gonna change this a little bit because we're not going to return anything. We're just going to execute the action over and over again. All right. And if we're going to do patrol, that means that it's going to continue to patrol, right? So And if I'm already in patrol state and I'm already executing that action, then, you know, again, what we want to do is we want to say that if it's going to change, then the only time we're going to call change state, as an example, is going to be when something is triggered. Okay, so we got to think about this, because updates, whenever we do things on an update, we want to check on update, we want to check it, but we don't want to trigger it every single time. We want to trigger the action once and let that action keep running. Run that action as long as possible. That's the action that's going to run every frame, right? Okay. So let's get back to state machine. So, all right, so we need to have getters and setters for initial state, current state, and target state. Let's do that first. So our getters for initial state, so we're going to return a state, which is, we're going to call this get initial state. And that'll definitely be a const. We're also going to get current state. That's also going to be const. We're going to get target state. Sometimes we need that too, and that's going to be const. So those are things that were, those are our getters. Pretty straightforward. And the same thing goes with set initial state. We're going to do this after the fact, where we have a state, and we're going to call this the initial state. All right, so that's the initial state. We're also going to set the current state. So current state, and we're going to set the target state. Target state. Again, these are, might seem redundant to you, but they're necessary to maintain our structure. And then what I want to do is I want to call an update function, or some kind of, the update function is going to call the action that's going to run. So I need an update function that's going to be public. And it's not going to return anything, but rather run it. So I'm going to kind of make a void function, right? It's going to be called update. And this update function is going to be called whenever I want it to be called. We could also call it, like, you know, make a decision like we did before. And remember, in the decision tree and the decision tree structure, we had something that's called make decision. We could have called this update as well, right? Now, one thing that makes decision did, if we looked at what we did last week, is we had a little, we called an internal update. That's what it did. And the internal update basically we checked to see if the line of sight was from the agent was called or not. And we may have to do something similar to this later on. So update is there, and that's kind of like an internal update function that is something that's running. So let's continue, and we're going to go to we need to also have a state machine.cpp. So we're going to go into core components. I want to add a new item. And we're going to say it's a CPP now, and it's going to be state machine.cpp. All right. So now we can generate definitions by declarations and do this kind of stuff. We're going to set these things to defaults, both of them. Okay, so both of them are defaults. We're also going to make sure that these are things are initialized. That's what this does. And get initial state, we're going to return m_initial state. We're going to return m_current state. We're going to return m_target state. We're going to say that m_initial state is equal to initial state. Like, all these are normal, regular things, as well as target state. Okay, but this is where the fun is in the update, method, because the update method or function, whatever you want to call it, is where all the fun happens. Okay? So what I want to say is that I want to return whatever action it is. And remember that triggered, right, is going to start off as nothing, right? So I'm going to say something like triggered is actually going to be a transition. So we're going to say transition, pointer, triggered. So trigger transition, okay? We're going to start this off as null pointer. We're gonna kind of set it as something. And then what we want to do is we're going to say this. We're going to say if for every transition in transitions that we have inside of our current state. So we're going to say that get current state, whatever the current state is, and we want to look at get the transitions. We want to make sure that the transitions, right, are not empty. So I want to make sure that if the transitions are empty, and this is where we're going to do some slowing down now. So this is going to check to see, okay, so check if transitions or the current state should have a number of transitions, right? Actually, maybe the better way to do this would be the for loop like we talked about before. So for, again, we can say for each, the way it's going to work is we're going to get a current transitions array. So get current state, whatever the current state is, and then the transitions. That's transitions for the current state. All right, that's the array. The element is going to be the transition that we're looking at. So if the for every transition, that's what we're going to say, in transitions, for every transition in transitions of the current state, we might have more than one. Then what I want to do is if my transition, right, is triggered, my transition is triggered. Now, why am I not getting this? Because transition, my friends, is not something that I've included. Let's include it. Transitions.h, right? If I don't include it, then I'm not going to get code hinting. So for every transition, if the transition's triggered somehow, then what I want to say is then trigger transition is equal to the transition. Okay, that's what's going to happen. So for every one that I'm going to go through, whatever the trigger transition is, if it's true, right? If I have a trigger transition, if it's triggered, then, and I'm going to go through one at a time, right? So if that transition is triggered, then I'm going to set it to this thing here. Okay. But here's the challenge. If I go through more than one, is there any way that I can trigger more than one transition? Well, our state machine says no. That means, could I have line of sight and detection radius in my control state? Could those both be triggers? I have both detection radius and line of sight. Is that possible? The answer is yes, it is possible. And depending on how I load the transitions, if I do a transition, I want to do the first transition that changes something, right? So I can't do both. I can only have one state at a time. I can't do both states. So it's the first state that I'm going to do. So if this transition is triggered, then I want to break out of the loop for every transition that's triggered. But my challenge is, I'm just going to go through this for a second. Take a look at what it says here. It does say that if the transition is triggered, break. Okay, a little bit ugly, but it is what it is. Okay, so that's what break does. I want to break out of the loop when I find my first transition that's triggered. Otherwise, it won't be right. And I want to load my transitions in importance order. That's another thing I want to do. Okay, next. Now, if I have a transition that means something, so if trigger transition is not null pointer, so it's something, right? if it exists, if it's not equal to null pointer, right, then we know that we've set it. Okay. Else, if it is equal to null pointer, right, so nothing has changed, right, therefore I want to execute the current action. So I want to say that m underscore current state get actions execute. So I want to execute the current action if I don't trigger a transition. Does that make sense? So whatever the current action is, I'm going to make it happen again. I'm going to play that action, right? Otherwise, if I've triggered a transition, then what I want to do is I want to move to that new state, whatever that state is. So a couple things to do, right? I want to, if my transition is triggered, I want to say that m underscore target state now is equal to, let's make it temporary, is equal to m underscore my triggered transition, whatever that is, right? And the target state. So triggered transition, and I want to get the target state. So did I not have that set target state? I don't think did I miss something? I think I missed it. Let's go back to that transition. I may have missed that piece. So is triggered get condition. Yeah, I forgot to do that. I need to get the target state, right, of that. So let's do that. Sorry. So state get target state. So I want to return that, right? That's the transition. Sorry about that. And let's add that in. Generate implementation. And I'm just going to return target state. Sorry, I forgot to do that. All right, go back to this. Back to the, we don't need this transition stuff. I want to go back to the state machine. And I want to save this. I don't care about the decision tree right now. We just care about the state machine.cpp. All right, so I'm saying get target state. So the target state is now the is something that I've set. Target state has been set. Okay, that's the target state. And then what I want to think about is once I've got the target state, right? You know, as an example, what do I want to do with it? Well, I want to basically, whatever the target state is, I want to say that a couple things, right? I want to have my current state equal to the target state, right? So current state is equal to target state, and I want to be able to play out that action, whatever the action is that I want to execute, right? Whatever the target state action is going to be, not the current action, but the target state action. And then when I come back to the update function, I'm going to keep playing that same action again. All right. So for the first time, what I want to do is I want to, now there's another way to do it. We could just switch states. So I could say that, you know, current state is equal to the target state. And I don't need the target state at all. I need to keep track of target states at all. And I think I might want to do it that way. Just looking at my previous code, I think that might be best. So I'm going to say something like m underscore current state is equal to the target state. Right? That's what we're going to do. And then when it loops around again, I want to keep playing the same action. So I'm going to basically say, let's execute that action. So I'm going to say that the current state action execute. And if because I'm doing it in both cases, right, whether I'm in the current state or the target state, then really I don't have to do this here. And I don't have to do an else. I can just execute the current state every single time. Whatever the current state is, I want to execute that action. And then we're just refactoring here to make it a little better. But the only thing is we just switch current state, whatever the current state is, to the target state. Okay. So that's kind of a shortened version of the update function. And now because we don't need target state, if I go back to the state machine.h, and again, I'm just using the defaults. The initial state we don't have yet. Okay, we don't have initial state. And we want to set the initial state to whatever it is. And the target state, we don't need anymore. So target state can go bye-bye. So we're just, notice how I'm just reducing, right? A little bit, because we have a lot of stuff in here that we had before and we don't need it, okay? Also, initial state. Are we ever using initial state for anything? So let's take a look. So in my target state, I'm definitely returning the target state. But do I need to is the question. So I don't think I need to do this. So I'm not going to return target state at all. And if I'm not returning target state, so set target state and get target state can go away. So again, I'm reducing, right? How about initial state? Do I ever use that anywhere in my code at all? So if I go back to initial state, we can see that I never really use it. Set initial state is really setting current state. That's what's happening. So my current state is what I want to set my initial state to. So really, at the end of the day, we don't need initial state either, just the current state. Okay. And then I can get rid of this. And I can get rid of this. Okay. Pretty simple. We're reducing, pretty straightforward. And then in my state machine, then I can get rid of all this and all of this. Again, really simple state machine we made, right? And on update, all we're doing is we're checking for each transition to see if it's triggered, and if not, how do I check to see if it's triggered? I need to have a way of triggering the condition, right? So I got to go through each transition, and for each transition, I got to check the condition, right? So that's something that's neat. That's something that I gotta figure out, right? So what if I set the condition for this to transition? Because remember, transitions have two parts: the condition and the transition. The state that I'm going to, something that's going to condition it, that's going to transition my state, right? So if I look at my transition.h, just for a second again, let's pull it side by side now. And then let's take a look. So I've got my is triggered. That's what it's being kind of looked at. I can get my condition and I can set my condition. So I want to be able to set each of the conditions that I have depending on the, there's different ones, right? There's line of sight. There's a bunch of them, right? And so what I need to do is I need to trigger, or I need to somehow have these transitions outside, or the conditions for the transitions somehow settable outside of this class. Because if I don't set them outside of this class, then how do I get to them? How do I ever have a transition that's triggered, right? Well, that means that the condition for that transition has to be set, whatever that transition is. Okay? So just mentioning it to you. All right, great. So we have this part. Now we need to build out our state machine. Let's put our state machine, our first version of our state machine, up online. A very simple one, by no means complex. We don't have multiple actions. We don't have any entry or exit. We simply have one simple action we can do. So home, I'm going to go to changes, and I'm going to go to added state machine class. So home, sync, and push. Now the usage and the testing is going to come into play, which is the biggest part and the longest part for us. And this is where I need your help, guys. Okay. So how do we implement? Well, back into scenes. If I go to scene, play scene.h, I want a new state machine now. So on the bottom of play scene.h, I want a new state machine. So state machine pointer, right? We're going to call it m_p state machine, just like we've done in the past for decision tree. And then inside of our placing.cpp, inside of our start method, below everything else, where we took away our decision tree, we're going to add in our state machine. So we're going to say m underscore. Now, I could build out my state machine here, and I could also have a build state machine function inside of my state machine, just like I did with my decision tree. So my decision tree, remember what we did? We hard-coded my decision tree to work. So in my decision tree.cpp, there was a spot where I build my tree. So I could do the same thing with my state machine, and that part is missing. I don't have the state machine, that I built out here, right? So I could do that. This is kind of like a hard-coded version where my tree is a specific type of tree that I made for this decision tree, right? And again, I can have multiple decision trees that have different nodes like this. I can make a decision tree that is that I build out differently, all right? But what about my state machine? Should I do the same thing? Or why don't we try a different way this time? So in my placeScene.h, I'm going to make a new function that's going to return void. It's going to be called m underscore build state machine. All right, so that's one thing that's going to happen, to build my state machine. Again, this could be inside the player class as well, all right, or the ship class. I'm going to, I want to implement this thing right here. And now when we think about this, I got to think about the requirements of what I'm trying to do. I'm going to call build state machine inside of my start method. So m underscore build state machine. This is the test. So test state machine. I'm going to build it out. And when I build it, I want to instantiate an object of type state machine. So I'm going to say something like, because remember, I'm making it a pointer. I don't have to, by any means, I don't have to make a state machine pointer. I can make it so it's a solid state machine object, right? But let's use it like this. So I'm going to say m underscore state machine is equal to a new state machine. Okay, so that's the first thing. So I've got a new state machine that's built. Yay. But the state machine requires stuff for it to be configured. For example, if I looked at my state machine that I have, that's inside of state machine filter, if I look at my state machine filter, right? So if I look here and look at my state machine, you notice that it needs a bunch of stuff. It needs to be able to my current state, and I need to set my current state. I don't have states, and states require transitions, and transitions require conditions, and conditions require, see what I'm saying? So I need to set all that stuff up first. We set up all that stuff first. So this is where the slogging comes into play. And I'm sorry about this, but this is, we got to go through it somehow, right? So before I make my state machine, then I'm going to do it at the end, right? Way at the end. But before I do that, I got to start thinking about defining my, kind of conditions. I want to kind of create some conditions, and I want to think about this. I want to be able to access these conditions as pointers outside of my state machine, so I can influence them or change them later on, right? Like every frame, I want to be able to change. Do I have a line of sight? Do I have detection radius? Do I have whatever? So therefore, inside of my placeScene.h, one thing I may want to do is think about making a condition, a set of conditions that are here, okay, in my placeScene.h. So let's do that. We'll say these are state machine properties. So we can say that we want to have a condition pointer. And my condition pointer is, we're going to call this m underscore has line of sight condition, right? So we want that. We also want a condition pointer for m underscore has, or you want to call it, kind of is within detection radius or something like that. Is within detection radius, right? So these are things that are going to be at the class level. right, that I can access and modify later on, right, these conditions. And I also want to make a float condition, which, so regular conditions and float conditions, and my float condition is going to be if I'm close to player. So m underscore m, and I probably should put p in there as well, just to keep the standards for coding. M underscore p, and again, it's like is within close combat range, or is within combat range, right? That's my float condition, right? And those are really my conditions. There's three conditions. I either have, because remember, if I look at my diagram again, look at this diagram. I'm either I can detect, I have line of sight, or I'm within, I'm close. If I'm not close or don't have line of sight, those are the opposite of these. So then, although I only have really three conditions, that's all I have in my simple state machine. Okay. But now I have them at this level, which means I can modify them and check them on update, do other things. All right. Again, what I'd want to do is have these inside of my ship. So I can say ship has line of sight condition, and I already do, by the way, because the ship has some of these things in there, right? I can set these properties up in the ship. I'm just decoupling right now because I want to test. That's why I'm doing it this way, because I don't know if it's even going to work, right? And I can't test unless I know. All right, so we're going to test slow, like I said. So let's go back. So we define conditions. We're going to say something like m underscore p has line of sight condition is equal to a new condition. And remember, I can, by default, it's false. Okay, so I don't really have to set it up right now because really it's not the value. I don't care about the value right now. Okay, and then m underscore p is within detection radius is a new condition. Also defaults, right, to false. That's what I set it up with, right, remember? And I have a flow condition, which is, so m underscore p is within combat range. And I think I just need to change this later on, which is a new float condition. And the float condition has some default values too, which I'm going to put in right now. But actually, here's where we can define those. We can define these. We can say that it's between, let's say, 0.0f and 2.0f, within 2 pixels. Am I within 2 pixels, right? And so those are the conditions. We've set up the conditions for the first time. Once we defined our conditions, again, we can figure out target distance. We can do if it's close to player. Right now, they're all false anyway, right? Because I have some kind of value between 0 and 2 as an example. And we need a value. So one thing is for this condition, let's rename it. So refactor rename. And we'll say that we're going to say is within, should be like that. Just like we've done within combat range, is within detection radius, has line of sight condition. And these are all conditions. So we can actually add that condition too. So we'll refactor rename so we have those things as there. I know it's big, but this way we don't get lost. We know what it is, right? And we can always make it smaller later and come up with an acronym or whatever. But it's this way it's clean. We know what it is. Has line of sight condition, is within detection radius condition, and is within combat range condition. We know that these are all conditions and what type they are. One thing to note is that in order for me to have this work, right, then we need something that is failing at first for is within combat range. So remember the float condition by default, it doesn't give me a default value, right, for these things. There's no default value. So again, what I want to do is if I go to definition for this, here's my definition. What I want to say is my test value by default, my test value is going to be something like, something that's going to make it fail, right? It's not going to be 0 because 0 would pass, right? And I always want to make my conditions fail first rather than passing, all right? So I'm going to say whatever the max value is, right, plus 1, right? So that's what it's going to be by default. So it's going to fail because my test value is greater than my max value, right? Then or lower than my min value. You can do it either way, right? By default, when I set up, it's going to fail. It's set to fail right now. So if I test this, if I call my test function, this is going to fail because my test value is not less than or equal to my max value, right? So there's going to be something in there that allows me to fail first before I pass. Okay, just a kind of a way we do tests. Fail first. Okay, so I set up my conditions, and now I got to set up my states. So again, set up states. We can actually say define states. Define states. Now, states are something that we want to set up here, but we don't care about what they're called or where they're at. We just need to start up with some stuff. So we'll say state, and we'll say patrol state. That's equal to a new state. And we're going to say state move to player state is equal to a new state. This is all set up. And then state is moved to line of sight state, and that's equal to a new state. And state, and that's equal to attack state, and that's equal to a new state. Okay. Just we define variables that are states. And now I got to add transitions. So define transitions. So I'm going to say patrol, these are instead of no, I was wrong. I want to define transition. So transition pointer, right? I'm going to say that, and again, I need to have my transition added in. If I don't have a transition here, it won't understand what I'm doing. So let's add in transition.h. State also, that's been added in my placing. So you can see that I should have state, a state machine. And because state machine, if I look at state machine.h, state machine.h has state, I don't have to define it because it's already defined. Because one thing kind of cascades into the other thing. But transition never been defined. So it uses it as a friend, but never been defined. So I'm going to say move to player transition. That's one transition, which is a new transition. And now I have some stuff. I have a condition that I can put in. My new transition is going to take two pieces, right? Which is the condition that I want. So m_p has line of sight condition and my move to player state. Okay. So I'm kind of linking, I'm kind of creating these pairs, right? Again, I can make a pair if I wanted to too, but that's not a bad way of doing it. I'm going to make a transition where it's move to line of sight transition, and that's equal to a new transition where I take m_p, and again, this would be the detection radius is within detection radius, and I want it, the state is going to be moved to line of sight state. Okay, and my transition, remember, there's only going to be 3 of these, is going to be called my attack transition, and that's going to equal to a new transition that is m_p is within close combat range. That's the trigger, and then my state is going to be attack state. Okay. Notice patrol state, nothing. There's, we got to think about that. I'm not even accessing my patrol state yet because my patrol state is something that is going to be my default state, and it's only going to have. There's going to be transitions but the transitions are going to be added to my state. Let's keep going. Now actions. So I'm going to have my patrol action. Let's add that in. Patrol action is going to be patrol action is equal to a new patrol action. My move to line of sight action is move to line of sight action, right? Is a new move to line of sight action. And did I not? Yeah. If I spell it properly. My move to player action is a new move to player action, and that's equal to a new move to player. Okay. And finally, my attack action is going to be called attack action, and that's going to be equal to a new attack action. And again, I want to add that in. These are all the actions. So you can see I've got to define all this stuff first ahead of time. All right, now that I've defined actions, transitions, states, all this kind of stuff, we're making it generic. Then I want to set up the patrol state. Here's our setup. My patrol state then is going to say something that looks like this. I'm going to say, hey, patrol state, I want to add transition. I'm going to add in my move to line of sight transition. That's the first one I want, right? Diagram. Patrol state, move to line of sight. I want to add the other one first. So move to line of sight. Patrol state, I want to add transition is move to player transition. Those are the two transitions that it has connected to the patrol state. And then I also want, hey, patrol state, I also want to add or set action. What's the action? The attack action. That's the attack action. So it's going to do the attack action. Okay. So my patrol state is done. Then I'm going to set up my move to player state. Well, only 3 of these, right? So move to player state is I want to add a transition. My transition is the attack transition, right? Why? Because if I'm in my move to player, I can only go to attack, or I can go back to move to line of sight. So then move to player state. I could also go to move, add transition, move to line of sight transition, because I could lose line of sight, right? That's possible. And then my move to player state action, so set my action to my move to player action. All right, that's my action. And then I want to set up my move to line of sight. Move to line of sight state. So move to line of sight state. I want to add transition, move to line of sight state. I'm only going to have one transition when it's going to move to player transition, right? So move to line of sight state, right? I can't go to attack and I can't go back to patrol state. I can only go back to player, which is what I'm doing here. Move to player transition. And then my move to line of sight states, and then my action, right, is going to be the move to player action. Make sure I'm right. Move to line of sight states. Move to line of sight move to line of sight action, not move to player. Move to line of sight action. Okay, so then all I'm doing is linking. I'm kind of adding, and I'm creating my state machine the way I want, just like we did our decision tree, right? Finally, set up attack state, and then it's attack state, and I want to add a transition where I have moved to player transition. That's a transition I can move to. I also have a attack state where I have add transition, and I have moved to line of sight transition, because I could have that problem too. I could lose line of sight, or I can lose the player's too far. So if player's too far, I do this one. If I lost line of sight, I want to get my line of sight back. And then finally, the attack state, the action is going to be the attack action, which makes sense, right? So move to line of sight action. I'm just configuring. This is all configuration without hard coding necessarily, right? This way I can create whatever states I want through my generic state machine. Phew, right? And what I want to do is I want to set my current state. So m_p state machine, and I want to set current state to my patrol state. Patrol state. Okay, there's my current state, patrol state. Okay, and let's see if any of this, we haven't called update yet. We're going to have a problem with update. Okay, we're going to have a problem with update, which we're going to spend the rest of the time doing, right? Let's see if this builds. So again, does it build? Do I have any initial issues, right? Because if we have initial issues, then it'll come up, right? And then we'll put this up on GitHub. Any comments? How are you feeling about this thing? Is it better or worse? Do you like this, the decision tree more? Does this make sense to you, what I'm trying to do here? Is it like wacky? Does it, does it compute for you, or not? That took a bit of time. Miguel says feeling lost. Okay, I know it's a lot, Miguel. It's a whole pile, right? Yeah, it's a lot of setup. It's a ton of setup. But then once you've set it up the first time, like you can see, like all this is setup, right? So this didn't crap out. So far, so good is what I'm saying, right? All right, so what we want to do is every frame then, on update, right? Instead of calling the update function right now, I want to say that I want to set up a couple things, and I only care about line of sight because that's all we have, right? So let's just do that. So if I have line of sight, I want to switch states. That's all I want to show. So again, that I'm going to say that m_p has line of sight condition, right? And what can I do with it? I can set the condition, or I can test, right? So set the condition, right? I want to set the condition to my line of sight condition, right? Which is, I want to say m_p, or my ship. If this check if the ship has line of sight is going to return void, right? That's what this thing does, right? So we made this function, right? Check ship line of sight. Let's go to definition for that one. So what this does is it goes to the placing and looks at the display object, and this is inside the placing.cpp, and then it doesn't return anything, but it says my ship has line of sight is equal to this, which means I want to get if my ship has line of sight. Let's go back. So this is what this is going to be. It's going to say m_p, right? Ship, and then get has line of sight. Get. Can I detect that? I can set has line of sight. Set has line of sight, but I can't get has line of sight. I have line of sight color, distance, whatever, but I don't even know if it has line of sight. Let's make a change to the ship to allow me to get line of sight. Oh, did we? we did. I was going to say, wow, that's weird that we don't have that. Yeah, so that's going to set up our condition. Set condition to this, right? If my condition is set to this, right, then when I go and do my update, so in my state machine.cpp, right, my state machine.cpp, when I do my update, it goes through and says, is it triggered? Well, I set my condition. If I set my condition, there's nothing that says it's triggered, right? So that means there's somewhere that I need to trigger the condition. I mean, to test it. So I'm going to say something like, okay, set the condition, whatever it is. And then I'm going to say that I want to test to see what the condition is. So I'm going to say that, okay, line of sight condition has line of sight condition. And I want to test, right? And what test does is it tests to see, it returns a Boolean to see if it's been triggered or not, right? That's what test does. So set condition sets it, tests it, right? That's what it does. And I don't want to do that here, right? I want to test it somewhere else, right? Is triggered. What does that condition look like when the is triggered condition for my my Boolean, right? My condition.h. So condition.h has a set condition and a test, right? And my my transition has an is triggered condition, is triggered, right? And the thing is, my transition doesn't check, right? If it's triggered or not, doesn't check. So again, there's lots of ways you can code this thing without being so convoluted, right? Instead of setting the condition, I could say whatever the transition is what it's going to be. But do I even have the transition that I want to set, right? Do I have it? Do I have access to it here? Well, the transition that I'm going to set is way down here, right? Where I'm saying that move to player transition is based on has line of sight condition. Has line of sight condition. And that is the thing that's being triggered on update. So if I go to update, it says whatever the condition is, right? My transition is triggered. Whatever, if I'm going to check to see if the condition is set, right? Whatever the condition is, if the condition is true, then is triggered is true. That's really what's happening, right? If the condition is passed, if the condition test, if the transition condition is passed, think about this, right? If transition, and then we have the condition, and we have a test, if this is true, do I really need is triggered, right? If the condition passes, then it's triggered. If it's true, then it's triggered. So this is something that I'd rather test. If my condition is test true, instead of transition is triggered. So there's a change right there. If my transition is passed, my condition test is true, then trigger transition is equal to transition if it passes the test, right? If it doesn't pass the test, right, then who cares? We just skip over this one, which means that in my transition method, if I go back, again, I'm just thinking about this. If my transition method, I don't need this, is triggered, then I can get rid of this, right? And because it's being held inside of my condition anyway, let's trim it down. So again, kill this, don't need is triggered, right? And I don't need to set is triggered, which means it's going to set up a bunch of errors on this side. This is all in implementation, guys. And this is gone here, right? So I don't need this at all because we don't care about it. We only care about the condition that's linked to this transition, if it's triggered or not, the way we've coded it. So we've simplified. Okay, since we've simplified, then, are there any other errors? So we haven't updated yet. All we've done is we've gone into playscene.cpp, and way up in here, what we've done is we've just set the condition of the ship whatever the line of sight condition is, we've set it so that it is matched with the ship. Okay, and then we get condition every single time in my state machine. So get condition is what we're looking at. We're looking at the condition test, we're testing the condition, and if the condition is passed, we trigger the transition. If not, we don't. Let's run this thing and see if there are any errors. I know guys running overtime, but we shouldn't have an error at this point. Awesome. All right, now the big test where we're going to fail. It's going to go through and it's going to check this, and this is where we typically fail. Why would we fail this test? Get transitions. Why would I fail the transitions test? It's going to give me a null reference error for transitions. And you're going to get an error like this again. Okay, programmers out there, why would I get a null reference error here? For every transition and current state transitions, right? Why would that be? So let's try doing the update function without doing it every frame, just once. And we'll do it once inside the placing.cpp at the bottom. So we'll say we made our state machine and now we're going to call the update function once. Because this is the test, right? State machine update. Okay, why will it fail here? If we've already done all this work and set everything up, there's something missing. Help me out. And this is the last thing we'll do together. And then we're good, right? So let's try it out. And why does it fail when we come to here? Would it fail? And look what it says, performing attack action. Is that right? Do I have line of sight? I mean, it's neat, but it's not right. Right? How did it get to attack action from patrol? So that's something interesting. We went to patrol action, right? And as soon as we went to update, we're updating and we're on patrol action right away. Well, let's look at this for a second. My has line of sight is a new condition, and by default, the condition is false. So it's false, right? And it somehow worked. Let's go back in here and take it out of here now, and let's see if we can put it inside of our update method. And why, if we put it in here now, will it fail? So we'll go here and say, hey, let's set the condition to this. What condition is it? Do we attack? Do I pass? Do I crap out? What happens? And it says we're performing the attack action. Why? I don't have a line of sight. It should fail, right? It's neat, but it's not what we want. Let's move my ship out of position. So does it really matter what we do here? Is my action, is my statement here. So here I'm performing move to player action. So I did something, look, right? Okay, and then when I move this off of this, right? When I move this off, it should switch it back. Move to player action is what it did, right? So that's kind of neat. It did make a change. So it kind of detected that one change, but we did the move to attack action thing. Okay, so let's take a look at that. First, we'll check the obvious stuff. We'll go into the actions and then look at the patrol action and see what it says. Move to performing patrol action. This says performing attack action. This says performing to move to line of sight action. This says move to player action. Those are the obvious ones that we want to check. Okay. So patrol, move to player, move to line of sight, and attack. Okay. We're very close to making this thing work, by the way. Okay. But why then do we have that weird error where when I start my game the first time, that somehow it says that I should attack? Oh, here we go. Current state says I'm not handling events. Let's try that again. I didn't do anything. Let's run it now again. And okay, I'm pretty good, but it's performing the attack action the entire time. And it should do this. It should do attack, 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 you know, over and over again, because that's what we've asked it to do. Okay, but why performing the attack action? And what if, again, if I was to move this outside of line of sight, no problem. But as soon as I have line of sight and I move into play, it switches states to move to player action. Let's see. That's another thing to check, right? So Samantha says, is the set action for patrol state the attack action? I don't know. Those are things to check. So yes, it is. Patrol action. Look at you, Samantha. You're awesome. Right? I didn't do it on purpose. I did it by accident. Okay, on accident. So, but that's awesome. So our state machine's working, guys. Right? It's convoluted, but patrol action, right? And why would it switch to move to player action, not the attack action? Well, remember, we have here, we're in patrol state, we don't have line of sight, and we don't have detection radius. And the only thing we're looking for is line of sight. And when I go to line of sight, it should transition to the move to player action, right? So let's go back to this, right? And this. And if I bring this up, and if I move my ship over here, and I move my target over there, then it should transition. Where it doesn't do it is because I have a bug with my has line of sight, it won't transition off. So even if I move my ship back down here, because this doesn't change, you know, as an example, because this doesn't change again back, except when it goes to there, where I lost line of sight, then this should go back to, what is it? It doesn't know what to do. It says move to player action right at this point. So I've got no line of sight, and this is interesting as well. So I'm here, and somehow I'm moving to player action, and I've lost line of sight. So what I should do is, if I've lost line of sight, it should transition back to move to line of sight search. To move to line of sight action. Okay. Sorry, the only thing I changed, Miguel, was this, patrol action. But you can see we've started forming out our state machine. It's not necessarily hard-coded, right? We've set it up, right? But we need to do some setup somehow. It's not automatic. It's not going to figure out what we want, but we've declared a bunch of actions, a bunch of behaviors based on a state machine as opposed to a tree. Different structure and a little slower than a tree. A tree, straightforward to set up, really quick to trigger, and it gives us our action right away. So basically the same that we did last time. No, it's not. Well, it is in terms of our behavior, but what I want you to think about is just two different methods. One using for screenshots. Yes, sorry. For screenshots, exactly what we did last time. Yeah. Because you need to show the behavior that we just did, right? All right, let's put this up on GitHub so you have everything. So there's nothing. So well, this is our final version. What we did is we fixed the, we actually finished the implementation of the state machine. So kind of implemented first draft of state machine. Now I'm saying first draft because it needs another go. Needs another pass. I don't have multiple transitions. I don't have multiple actions. You know, I only can do one. I don't have entry actions and exit actions. I only have one thing I can do, but it works, right? And I'm going to sync and push. All right, any questions around this? Again, guys, I think this is a very straightforward way of doing it. You know, but where my worry is all the setup, all this stuff that I have to, you know, kind of create these structures that I have to put together to set up my state machine. And what if I had a more complex state machine? If I did it with enumerations, right, then what we're going to get into is real convoluted switch case. There's no switch case here. It's a for loop, right? We go through the for loop. We go through each transition. And when there's a transition made, we move to the next state. That's what we're doing, okay? There's some troubleshooting to be done, definitely some troubleshooting, because, you know, things don't quite work out the way we wanted, right? But it's pretty good. And so from a goal perspective, we've taken care of a couple of things here, just to say, from a first draft, we've done all of this. So all of these got done, right? And we built the state machine, we did this, and we even run the state machine at least once. So we've done all of this stuff. We've converted everything and tried it out. All right, any questions before we go for the day? I think there's a lot here, guys. I know there's a lot of coding, and I told you there's going to be a lot of coding in this one. And I know the things pieced together, but guys, if you have questions or you're confused, I tried to keep it as simple as I could. Please make sure you take a look at the video again. Try and do what I did. Try and go through and create your state machine and read through some of the pseudocode. Like literally what I did was I stepped through each step of the pseudocode and tried to make heads or tails of it. Yes, definitely make the code. What I would recommend for screenshots is kind of like what Nikolai said. I would kind of open up this and show this part, because this is the stuff that we've changed for our state machine. We have all this. And when you run it, I always recommend, kind of making a couple of runs and showing the output. So again, things like when I'm running it, and you can see that I'm patrol action, and then when I move my ship, as an example, up to this, and I have line of sight finally, then it switches to player action. And if you can capture it so it shows you the difference, performing move to player action as opposed to something else, this is really great. Because really that's the first switch. Once we do one, we can fix it so I can do it all the time, and then it'll have behavior that it's following very simply. And again, this is a more complex state machine. We can also do a hard-coded state machine. Great thing about this is it's extensible. You can copy it. You can make different kinds of state machines. I can use that build, so I can make a state machine for a close combat character. I can make a state machine for a ranged character, or one that has both. The idea here is that you have lots of range. You have lots of possibilities. That's it for me, guys. I'm going to stop recording this, and I'll take questions about your assignment now. All right. Any